Well, hello, good night. My name is Jorge Luis Ramirez Hernandez, and now I'm going to present my assignment number 4 in ship structure. So, the problem number 1 has the problem to analyze a component of fluid. First of all, we need to identify the part of the beam that we want to analyze. In this case, we need to make our FBD, yeah, FBD. In this case, we will have a reaction in A and a reaction in B, and a distribution force. In this case, we're going to name it PO. Yep. And also we have a longitudinal value, well, in this case, you have the data of the problem. We have that. We have the force of the spring. We have the double bottom and the other ones. And after that, we need to define the beam that we analyze. So in this case, this is our clamped beam in both sides. So the boundary conditions, we have the deflection 0 and the slope 0, 2. And after that, we need to use the approximation in the method of the energy. So um, we need to identify our polynomial, and after that, when we use the function of the exercise, we need to separate the U in two parts, the U of the bending and the U of the spring. And also, after that, make all the process, you will obtain the first value. In this case, it's in the key, the value of the spring times A1 over square over 512. You need to make another process for the U of the bending, and propounding a integral, in this case with double deflections. And after you make all the process, you will have the other value of the beam. This case is the last one in this part. After that, you need to have the total of the U of the springs, of total of the energy. You need to plus this value. But after that, you need to make you need to have the another component of the formula. In this case, is the P, and also you need to propose another function. This function you will be integrate, and after that you need to plus of the values. In this case, to calculate the inertia, we need to propose the table of inertia, and when you have all that values, you have you only need to replace the value in the formulas in the no in the all the values that you obtained before. So with that, you can calculate the value of A1, and you can calculate the normal stress with that all values, because the E is the Young modulus, inertia that we already obtained it, and that's all. Man, make all this exercise have like no. That my work hours in this exercise is 3 hours. Now, exercise number 2. In this case, we need to analyze another beam. And so the boundary condition for this one, it's for a clamped beam too. No, a simple supported beam. And after that, you need to propose the we need to propose another another approximation. In this case, like we have a beam clamped in both sides, but with force in the axial part. Basically, they going to are going to deflect like this. So in that case, this is like a no like a Higgs bending. So you need to use trigonometrical identifiers. So that was that we proposed in this first part. We need to derive this value two times, and after that make basically the same process in the last part because we need to use that double derivative and we need to make the integral for that part, and after that use the function of the critical or the critical to obtain the critical value. And moreover, with that, just only replace the values. And it was necessary to remember that we have uh, different types of values of lambda. In this case, this is like a or parameter, and you will take these values. So that's all. Thank you.